Welcome. In this lecture, we shall solve the final problem on slope and deflection in beams using Macaulay's method. Solved problem 20 is stated as follows. A beam ABCDE of 7 meter span is supported at A and D and loaded as shown in the figure. Find the deflection at point E and the slope at end A. Given Young's modulus is equal to 2 times 10 to the power of 5 megapascals and area moment of inertia is equal to 5 times 10 to the power of 6 in millimeter raised to 4 units. The given beam is shown and labeled. We first find the reactions at the supports A and D by initially assuming both to be acting in upward direction. We consider the whole beam in static equilibrium and write the balance equation for vertical forces and the balance equation for moments about point A. Solving, we get the reaction value at D equal to 525 newtons acting in upward direction. The reaction value at A is found to be minus 125 newtons, minus indicating that the reaction is acting in downward direction as opposed to the upward direction as originally assumed. We show the reactions in the beam loading diagram for our reference. Now, let the coordinate system be shown at point A. The moment equation is written from the differential equation of elastic curve, valid for the entire length of the beam in the form of half range or singularity functions. We perform successive integrations with the inclusion of unknown constants C1 and C2. Next, we introduce the boundary conditions, namely deflection is 0 at x equal to 0, that is for point A, giving the value of C2 as 0. Also, deflection is 0 at x equal to 4 meters, that is for point D, giving the value of C1 as 237.5. The final equations for the slope and deflection are now written for our reference. The deflection at point E, that is for x equal to 7 meters, is found to be 3.59 millimeters acting in downward direction. The slope at end A, that is for x equal to 0, is found to be 2.375 times 10 to the power of minus 4 radians or 0.0136 degrees. The deflected shape of the beam is finally drawn in the beam loading diagram for reference and interpretation. We hereby complete the solved problems on slope and deflection in beams. In the next lecture, we shall look at some practice problems.